Section 2.3 Modeling with Linear Functions. In this section, we will explore examples of linear function models. And remember these steps: how to, given a word problem that includes two pairs of input and output values, use the linear function to solve the problem. Number one, identify the input and the output values. Then you convert the data to two coordinate pairs. Then find the slope. Write the linear model, the equation. Then use that model to make the prediction by evaluating the function at a given x value. Use the model to identify the x value that results in a given y value and answer the question posed. And this is what we're going to do for the first problem. Example 1. A town's population has been growing linearly. In 2004, the population was 6,200. By 2009, the population had grown to 8,100. Assume this trend continues. Letter A. Predict the population in 2013. Identify the year in which the population will reach 15,000. So based on this problem, what are the two changing quantities? Yes, the population and the population size and the time. So we will define our input and output here. So input, we have that for the time, because you have the 2004, 2009, so we can use the time t. That is the years since 2004. And then our output is, since we want the population size, let's use p of t. So that is the town's population. This problem gives us two input-output pairs, the time and the population size. Notice that we start at 2004, so that would correspond to t equals 0. So we can have our coordinate pair 0 and 6200. And the other one, by 2009, so from 2004 to 2009, that is 5 years. And the population had grown to 8,100. So remember, this is from 2004 and this is 2009. It would be better if we use 0. And with this, now you're gonna have your y-intercept. But now you have the coordinate pairs. We will be able to solve for a slope. So these are your x1, y1, x2, y2. So solve for the slope. A100 minus 6200 over 5 minus 0, and 8100 minus 6200, that is 1900, divided by 5, and that is 380. That's the population per year, or we can say 380 people per year. And now with this, we'll be able to write our equation. So P of t is equal to 380t, and our y-intercept, that is when x is 0, is 6200. Okay, so take note of this. This is our equation. Now to answer letter A, predict the population in 2013. So from 2004 to 2013, how many years is that? Yes, 9 years. So we're going to predict when t equals 9. So we're going to predict when t equals 9. So let's do that. Let's use the linear model here. So when t is equal to 9, so 380 times 9 plus 6200. And 380 times 9, and if you add it with 6200, that is 9620. So that is letter A. The next, letter B, identify the year in which the population will reach 15,000. Population will reach 15,000. So you plug in 15,000 to your P of t. So meaning P of t is equal to 15,000. So let's use that. 15,000 is equal to 380t plus 6200. Now we will be able to solve for t. Subtract 6200 both sides. That is 8800 is equal to 380t. Then divide both sides by 380, so that t is approximately equal to 23.158. So our model, this is our linear model, predicts the population will reach 15,000 in a little more than 23 years after 2004. So that is like in the year when we add 2004 and 23 over 2027. Okay, so take a look at this example. What we did here, first identify the input and the output, and then get the coordinate pairs based on the problem for you to do solve the slope here, which is m equals 380 people per year, and then with that slope and this y-intercept, you'll be able to write the linear model, the equation. Then you can answer now the questions. Letter A, predict, meaning you plug in that to your linear model from 2004 to 2013, that is t equals 9, and you'll be able to solve that. Then letter B, identify the year in which the population will reach 15,000. So 15,000 is the population, so that is P of t. So plug in that to your linear model. 15,000 equals 380t plus 6200. Solve for t. Okay. Next, example number 2. Using a diagram model to model a problem. Anna and Emmanuel start at the same intersection. They started here. Anna walks east at 4 miles per hour. This is to the east, 4 miles per hour. That's Anna. And Emmanuel walks south at 3 miles per hour. So this is Emmanuel. That is 3 hours 3 miles per hour. They are communicating with a two-way radio that has a range of 2 miles. How long after they start walking will they fall out of radio contact? In essence, we can partially answer this question by saying they will fall out of radio contact when they are 2 miles apart. But how long will it take them to be 2 miles apart? So first, let's identify our input and output. Our input is, again, the time t in hours. And output, we have for Anna a of t in distance in miles, and Emmanuel, let's use e of t. Again, both distance in miles. Find the initial value. They both start at the same intersection here when t or time equals 0. That is, the distance traveled by each person should also be 0. So thus the initial value for each is 0. Then the rate of change for both, Anna is walking 4 miles per hour and Emmanuel is walking 3 miles per hour. So they have those rates of change, whereas the slope for Anna is 4 and the slope for Emmanuel is 3. So we can write a of t is equal to 4t and e of t is equal to 3t. Now, next is to represent Anna's position from here to here. So let's use this as variable a. That is to define as the measurement from the starting point in the eastward direction. And let's use this as e for Emmanuel, and this one is the distance d. And what do you notice about this? E, A, and D. That is like a right triangle. And it shows that we can use Pythagorean theorem. Do you remember Pythagorean theorem? So this is the hypotenuse. So that is d of t squared equals a of t squared plus e of t squared. So remember, a squared plus b squared is equal to c squared, the Pythagorean theorem. So d of t squared, our a of t is 4t, so 4t squared plus e of t is 3t. 4t squared is 16t squared, 3t squared is 9t squared, 16 plus 9 is 25t squared. So this is our d of t. And since we are solving for t, then use the square root both sides. So the square root is going to be equal to square root of 25t squared is plus or minus 5t. But since we're talking about distance, there is no negative distance, so that's why we only use the positive. Next, it says here they are communicating with a two-way radio that has a range of 2 miles. So we can say that d of t is equal to 2. And since we have d of t equals to 5t, so we could use that, substitute this to here. So 2 equals 5t. Now we can solve for t by dividing both sides by 5. So t is equal to 2/5, or is approximately equal, is exactly 0.4. So they will fall out of radio contact in 0.4 hours. What is 0.4 of an hour? That is like 24 minutes. Okay. And there is a question here: should I draw diagrams when given information based on geometric shape? Yes. Sketch the figure and label the quantities and unknowns on the sketch, just like what we did. Next problem: using a diagram to model distance between cities. Example 3. There is a straight road leading from the town of Westboro to Agrietown, 30 miles east and 10 miles north. It would be better if we use a diagram, a picture of the situation. So that is from the origin, from town of Westboro to Agrietown, 30 miles east and 10 miles north. That's why you have these coordinates 30, 10. Partway down this road, it junctions with a second road perpendicular. This is the second road, which is perpendicular. That's why you see that box here, 90-degree angle, perpendicular to the first, leading to the town of Eastboro. If the town of Eastboro is located 20 miles directly east of the town of Westboro, that's why you have the 20 here. How far is the road junction from the Westboro? Using this and from the origin, we can find the slope. So m, so let's use 0, 0 and 30, 10. So the slope is 10 minus 0 over 30 minus 0 is 10 over 30, and that is equal to 1/3. So the equation of the road from Westboro to Agrietown, would be W. Let's use W for Westboro. So W of x is equal to the slope of 1/3 x. From this, we can determine the perpendicular road to Eastboro. We have a slope of, since this line is 1/3 x, this is perpendicular. So remember from the concept of perpendicular, the slope is going to be the negative reciprocal of 1/3. So for that, you will be able to write E of x equals negative reciprocal of 1/3 is negative 3x plus the y-intercept. Then let's use this 20 is 0 as your xy. So this is 0 equals negative 3 times 20 plus b. Negative 3 times 20 is negative 60. And if you add 60 both sides, your b is going to be 60. Now we can have an equation for this line perpendicular to that as E equals E of x is equal to negative 3x plus 60. Now we have the two equations. Again, the orange line here is W of x equals 1/3 x, and the blue line here is E of x equals to negative 3x plus 60. And then we want the point of intersection. Remember, when we get a point of intersection, you make them equal, set them equal to each other. So here 1/3 x equals negative 3x plus 60, and then solve for x. So subtract 60. When you subtract 60, 1/3 of 60 is 20. Oops, sorry. No, not subtract 60. It would be better if we add 3x. So it's going to be 1/3 x plus 3x is equal to 60. What is 1/3 plus 3x? 3 times 3 is 9. Plus 1 is 10 over 3x is equal to 60. And then multiply both sides by the reciprocal of 10 over 3. It's like 3 over 10. So that 3 times 10 over 10 times 3 is 30 over 30 is equal to just x. And then 3/10 of 60 is 60 divided by 10 is 6 times 3 is 18. So x is equal to 18. And we can solve for our y. If we plug in 18 to either of the two, w of x or e of x, so I guess it's easier if you use wx. 1/3 of 18 is 18 divided by 3 is equal to 6. So we have the point of intersection at 18,6. So this is the point of intersection and the coordinates are 18,6. And now last one is we want to get how far is the road junction from Westboro. So how do we get that? So this is the road junction and this is Westboro. How far is this? So what is this distance? Okay, so distance formula, if you remember, that is x2 minus x1 squared plus y2 minus y1 squared. So we're using this point, the point of intersection, and Westboro because we want the distance from Westboro to this junction. So 0, 0 and 18, 6. So this is like square root of 18 minus 0 squared plus 6 minus 0 squared, and that is like 18 squared plus 6 squared square root. Use the calculator and you will actually get the distance approximately equal to 18.974. And that is the final answer. Okay, so let's recall. So what did we do here? So first identify the coordinate pairs. So that this is like our first step, step number 1. And then step number 2, solve for the slope. And then you will be able to get the equation. And the other one from Eastboro to get this after you get the y-intercept, and after you solve for that, since now you have the 2 lines, step number 6, you will be able to find the point of intersection by making them setting them equal to each other, and this is the point of intersection. And then you can answer the last question, which is to find the distance. Okay, so try this on your own. Next slide. Building systems of linear models. So real-world situations including two or more linear functions that may be modeled with a system of linear equations. Just like the first one, letter A, there is exactly one solution when two lines are intersecting, and infinitely solutions if they are the same, and no solutions if they are parallel lines. All right, example number 4. Building a system of linear models to choose a truck rental company. Jamal is choosing between two truck rental companies. The first, Keep on Trucking, charges an upfront fee of $20, then 59 cents a mile. The second, Move It Your Way, charges an upfront fee of $16, then 63 cents a mile. When will Keep on Trucking be the better choice for Jamal? Define these values here. The input based on the problem is the distance driven in miles, so let's use that as D. The outputs, we have K of D and M of D. Keep on Trucking and Move It Your Way. Initial value, upfront fee when it is 0 is equal to $20, and the other one for Move It Your Way, the first payment is $16. Rate of change for K of D, that is 59 cents a mile, so 0.59, and for Move It Your Way is 63 cents per mile. Okay, so with this, we will be able to write our equations. K of D is equal to 0.59D plus 20, and for our M of D is equal to 0.63D plus 16. Then set the two equations equal. So K of D equals M of D. So 0.59D plus 20 is equal to 0.63D plus 16. So if I subtract 16, this is going to be 4 equals to 0.63D, and if I subtract 0.59D, that's going to be 4 equals 0.04D, and divide both sides by 0.04, so D is equal to 100. So this tells us that the cost from the two companies will be the same if 100 miles are driven. By looking at the graph, see the two graphs here, and you see the point of intersection here, or noting that K of D is growing at a slower rate, we can conclude that Keep on Trucking will be cheaper price when more than 100 miles are driven. Okay, that is when D is greater than 100. Okay. And that's it for this section 2.3, modeling with linear functions. Thank you.